In this video, I'd like to talk about the math question of the day for Tuesday, July 11th, 2023. And with this problem, we need to simplify these radical expressions while assuming that y is a positive number. And simplifying square root expressions is typically taught in Algebra 1. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And with simplifying, it is helpful to assume that our variable is positive, since then we won't deal with any issues with imaginary numbers. Though in this case, we wouldn't have that anyways because we're raising these to even powers. But we can start by looking at the coefficients on these radical expressions. And since we're multiplying all of these together, remember with multiplication, you can rearrange the order without changing the final product. So we can do 6 times 2, which is 12, and we can put that out front. Then we have the square root of 15 y to the 4th, and we're multiplying by the square root of 20y squared. And with square roots, if we are multiplying two square roots together, we can combine them into one big square root where everything under the square root is then multiplying together. So in other words, if we have root a multiplied by root b, this is equal to the square root of a times b. And writing this all as one multiplication problem, we have 15 times by 20, which we could write as 300, or we can keep them separate. And we have y to the 4th times y squared, which is y to the 6th power. Now, the key strategy here is that we want to find the perfect squares underneath the square root. Since we know that if we have the square root of x squared, that this is just equal to x, assuming that x is a positive number. Since the square root and the square cancel each other, if we have the square root of 3 squared, or the square root of 9, this is equal to 3, and you can see that the square root and the square cancel. So if we have a perfect square, like 3 squared, underneath a square root, the square root and the square will cancel, and we'll be able to take out that base of 3 in this case. So to do that, we want to take this number 300 and make a tree with it to find its prime factors. So let's take 300. We know that 300 is a product of 15 and 20, which is why I mentioned that we don't have to multiply them together, since in reality we'll be splitting them apart. And 15 is a product of 3 and 5. 20 is a product of 5 and 4. And 4 is a product of 2 and 2. So at this point, we have our prime factors, 3 times 5 times 5 times 2 times 2. We can actually just write 300 as 3 multiplied by 5 squared multiplied by 2 squared. And let's rewrite all of this under the square root. We have 12 multiplied by the square root of 300, but we know this is just 3 multiplied by 5 squared multiplied by 2 squared. And with y to the 6th, we can do the same thing. We can break this up into perfect squares. Y to the 6th is really just y squared times by y squared times by y squared. Let me just make a bit more room here. And we'll basically just use this fact now. But before we do that, we will use this fact. If we have a product under the square root, we can rewrite them as individual square roots multiplied together for each of these factors. So let's do that. And honestly, this is a bit tedious, but this will explain it in full detail what we're doing here. In practice, at this point, you can just pull out all the perfect squares once you recognize which numbers are squared. But let's write it more explicitly, just so that we can see the pattern. And we're multiplying all of these factors, so they will all get their own square roots multiplied together. We have root 3 multiplied by the square root of 5 squared multiplied by root 2 squared, and then we have root y squared times root y squared times by the square root of y squared. And for each of these are all perfect squares, so the square root and the square will cancel. The only thing that will remain under the square root is the 3. So this term right here will be the only term at the end that remains as a square root term. So let's simplify everything now. We have 12 out front. Then the square root of 5 squared, the square root and the square cancel, and we just get times 5. Here, the square root and the square cancel, and we just get times 2. You could also think that this is just the square root of 4, which we know is 2. For each of these will be equal to y, since square root and square cancel. So we get y times by y times by y. And for our final answer, we will just multiply everything together. We have 12 times 5, which is 60, times 2, which is 120, and we have 3 y's multiplied together, which is y to the third, and I realized I made a mistake. I lost this square root of 3 here, so let me quickly put that in. I did mention that we would still have this at the end. It's the only one that wasn't a perfect square, and so we couldn't simplify it and lose that square root term. And now, multiplying everything together, we know this is 120. This right here can be rewritten as y to the third power, and we still have this root 3. So this right here will be our final answer. And if you want, what you can do to check this is pick some value of y, maybe a y value of 2, plug it into your original expression, simplify it, and then plug that same y value into this new expression that you found. And if you get the same answer for both, then you know you did this correctly. And I will leave that as an exercise for the viewer.